Hello friends, welcome to Learner's Planet. Friends, this is our first session for time, speed and distance. Friends, this topic is very important as far as competitive examinations are concerned. Good number of questions are asked from this topic in various entrance examinations like CAT, MAT, GRE, GMAT, and maybe we talk about bank probationary officers examinations and other examinations. Okay. Friends, it's very interesting topic and we come across the applications of time, speed and distance in our day-to-day life. Friends, I would advise you do not mug up too many formulae to deal with various types of questions. Just think logically, apply some common sense and you will get the answer to even difficult problems. Further, I would repeat that there is no shortcut. All of these are the smart and logical ways to solve the problems. And by practicing good number of problems and questions, logical and analytical thinking can be improved as well as enhanced. So let's begin our journey to time, speed and distance. And I'm sure you must be having your paper and pen with you. So let's begin. Friends, let's understand the relationship among these three terms, that is time, speed and distance. Suppose it is a place X and it is a place Y, and the distance between these two places is 100 kilometer. Okay, now the distance, that is 100 kilometer. Okay, now if I wish to cover that distance in 2 hours, okay, or I'm covering that distance in 2 hours, that means per hour how much distance I am covering. If I'm covering 100 kilometers in 2 hours, that in 1 hour I'll be covering 50 kilometer. Okay, now this 50 kilometer is actually my speed. That means the distance covered per unit of time is called speed. Okay, distance covered per unit of time is speed. Now, if this distance is suppose in meters, say from X to Y, it is maybe 200 meters. Okay, and I wish to cover that distance in say 20 seconds. Okay, that means 200 by 20, that is 10 meters, and it's 200 meters and it is 20 seconds. That means 10 meters per second is my speed. Okay, so speed is actually distance by time, or we can say distance covered per unit of time. Distance can be in kilometers, meters, miles or any other unit, and time can be in hours, minutes and seconds. So precisely speed is distance covered per unit of time. Okay, so I hope you are clear about the concept of speed. Now let's take the concept of time. Now suppose the distance between these 2 points or places is 100 kilometer and our speed is 50 kilometer per hour. Then how much time will take to cover this distance? Every hour we are moving 50 kilometer. That means to move 100 kilometers we need 2 hours. So what is the time? It's 2 hours. Okay, very simple concept. And now let's see how could we find the distance between 2 points. Suppose from X to Y I have to go, and I can maintain a speed of say 100 kilometer per hour. Okay, it's the speed which I can maintain. And if I'm taking 3 hours to cover this distance, then what is the distance? Every hour I am moving 100 kilometers. So in 2 hours I'll be moving 200 kilometers. In 3 hours I'll be moving 300 kilometers. So the distance between these 2 points is 300 kilometers. Okay. So as we have already discussed, the units of distance is kilometers, meters, miles, etc. And similarly, the units of speed will be kilometer per hour, meter per second, or meters per minute. So according to the question, we have to see. Okay. Friends, one important thing we have to keep in our mind that whenever we talk about speed, in these sort of cases, we always talk about average speed. Okay. These are the two places, and suppose the distance between them is 120 kilometer. And we are taking 2 hours to cover that distance. That means the average speed is 60 kilometer per hour. Suppose why we are taking it as an average speed? Because it is practically not possible to drive at the same speed to cover up the entire distance. What happens, sometimes the speed increases, sometimes the speed decreases. Sometimes, yeah, because of maybe traffic problem, some stoppages are there. So we cannot consider all the facts. So what we consider is what was the total distance covered up in a unit time. Okay, so the total distance which was covered up in unit time, here it is 60 kilometer. So it is covered in 1 hour. So the average speed is 60 kilometer per hour. Okay. Now let's say the conversion of units. Speed, as I have already discussed, that it is in kilometer per hour or in meter per second. So we have to be very clear about in which unit we are working. So sometimes to solve the questions, we need to convert the units from one to another. Okay. Now, suppose we wish to convert kilometer per hour to meter per second. What happens? Suppose it is x kilometer per hour. Now, 1 kilometer is 1000 meters and 1 hour is 60 minutes, and per minute 60 seconds are there. So 1 hour is equal to 60 into 60, that is 3600 seconds. Okay. Now if I wish to convert kilometer per hour to meter per second, what I'll do is 1 kilometer is 1000 meter and 1 hour is 3600 seconds. Just write seconds over here. So it is 5 by 18. That means x kilometer per hour is equal to x into 5 by 18 meter per second. So if you could remember this calculation, you can easily convert kilometer per hour to meter per second. And similarly, if you wish to convert meter per second to kilometer per hour, you have to multiply it by 18 by 5. Okay, very simple calculation is there. If you can memorize it, it would be great. If you cannot, then you can calculate it immediately whenever it is required. Okay. Precisely, we should be flexible enough to convert from one unit to another. Okay. Now let's understand the concept of average speed. If a certain distance is covered at x kilometer per hour and the same distance is covered at y kilometer per hour, then the average speed during whole journey is given by 2xy over x plus y kilometer per hour. Now friends, let's assume these are the two places and the distance between these two places is b. Okay, now I'm going from A to B. That means I'm going in this direction at the speed of x kilometer per hour. And further I'm coming back from B to A at y kilometer per hour. Okay, so in that case, what is my average speed? Average speed here is the total distance and that divided by total time. That means how much distance I am covering in given time. Okay, so that is the average speed. Now let's try to calculate how could we find out the average speed. Now suppose while going from A to B, I am taking maybe t1 hours. Okay, since I am going at the speed of x kilometer per hour and I am covering d distance and I am taking t1 hours. That means distance d is equal to x into t1. Okay. Now, similarly, while coming back, I am covering the same distance d at the speed of y. Okay. That is y kilometer per hour. So what is the distance? It is y into t2. Let's assume I am taking t2 hours. Now we have already discussed the concept of average speed. It should be what is average speed? It should be total distance by total time. That means total distance of the journey and total time taken to cover up that particular distance. Now what is total distance over here? It is, I just write it over here, average speed is equal to total distance by total time. Okay, just a moment. Now what is the total distance which we are covering over here? It's while going it is d kilometer and while coming back it is further d kilometer. That means total distance which we are covering is 2d kilometers. Okay, and what is the total time? That is t1 plus t2. Now t1 is what? D by x, and t2 is what? D by y. So the total time is d by x plus d by y. Now let's solve it and we'll be getting the average speed. It is 2d over, let's take ds common. We'll be getting x plus y by xy. Okay. So just solve it over here. It is 2xy over x plus y. Okay, that is average speed of this journey. Okay, so this is the direct formula and you should be clear about the concept of average speed, that it is total distance by total time. Sometimes it happens that these speeds are in maybe sometimes it is x kilometer per hour, y kilometer per hour, and 1/3 speed is also there. In that case, we have to further develop a formula. So to avoid all these criticalities, it is better to go for the conceptual studies. That is, you should be keeping in mind that average speed is total distance by total time. Now, let's try to find out if the average speed, if there are three different speeds to cover up the same distance. Okay, now suppose this distance is d, d and d. This is an equilateral triangle and all three distances are same. Okay, now suppose this speed, that means speed to cover up this distance, that is BC, is maybe x kilometer per hour, it is y kilometer per hour, and it is z kilometer per hour. Now we have to find out the average speed of the entire journey. Suppose we are starting from A, then we are reaching to B, then from C to A. That means the complete journey of ABC, and we have to find out the average speed. Okay. Now once again, what is the average speed? That is total distance by total time. Okay. Now let's assume to cover d distance at x kilometer per hour, the person is taking time t1. Here the time is t2. Here the time is t3. Okay. Now what t1 is? Distance upon speed. So distance over here it is d and speed is x. Similarly, t2 is d by y and t3 is d by z. Okay, now that let's calculate the average speed. It is total distance by total time. Now what is the total distance? That is d plus d plus d, that is 3d. And what is the total time? That is t1 plus t2 plus t3. Now let's put the value of t1, t2 and t3 in terms of x, y, z and d. So it is 3d over t1 is d by x, t2 is d by y plus d by z. So it is equal to, let's calculate it over here. It's 3d. Let's take d as common and LCM of 1 by x plus 1 by y plus 1 by z. Okay, it's 3 upon, let's take the LCM, x, y, z. Here it is yz plus zx plus xy. So finally it is 3xyz by xy plus yz plus xz. That is average speed. Okay. Friends, we have seen the derivation of average speed when to cover up the same distance 3 times, 3 different speeds are there. Okay, so in that case we can calculate the average speed by this manner. But further, I would recommend you not to mug up too many formulae. Just try to understand the concept. Here, all the values are in variables. And if these values are fixed, that means for a particular question, these values are fixed, then the same way you can calculate the average speed. Okay, no need to mug up any formula. Okay. Now let's see the next concept. If a person changes speed in the ratio m is to n, then the ratio of time taken becomes n by m. Okay, that means I would just write the formula here once again. Speed is equal to distance and time, distance over time. Now friends, you might observe that speed is inversely proportional to time. That means if speed increases, then to cover up the same distance, the time will be reduced. And if speed decreases, then to cover up the same distance, the time will be increased. That means speed is inversely proportional to time. Now, just take a very simple example. To cover up a distance, if you reduce your speed to half, then definitely you will be taking double time of your usual time. And if you reduce your speed to 1/3, then definitely you'll be taking 3 times the usual time. Okay. So similarly, if you are if you are doing your speed to 3/4 of the usual, then your time will be 4/3 of usual. Okay, and any fraction can be there. If your speed is 4/5, then your time will be 5/4. If your speed is 7/6, then your time will be 6/7. So if you increase your speed, the time is reduced from the usual. If you decrease your speed, then time is increased from the usual, and it is in the this sort of proportions. Okay, I hope you are getting my point. Now friends, let's see the new concept. If two persons or vehicles or trains start at the same time from 2 points A and B towards each other, and after crossing they take x and y hours in reaching B and A respectively, then speed of first by speed of second is root y by x. Friends, very interesting concept. Let's try to derive it. Okay, now suppose there are two places, here it's A and here it is B. Okay, and a person P is going in this direction and person Q is going in this direction, and they are meeting somewhere here. Suppose this is point O. Okay, now after meeting this person, P is taking x hours to cover up this distance, and after meeting Q is taking y hours to cover this distance. Okay. Now, since they are starting at the same time, we assume that they are meeting after t hours. Okay. Also, we assume the speed of P is V1 and speed of Q is V2. And since they are meeting after T hours, with this speed, P must be covering V1T kilometer. Okay, P must be covering V1T kilometer and Q must be covering V2T kilometer. Okay. Now, P is covering V1T kilometer, that is this distance. So I just write over here V1T kilometer, and Q is covering V2T kilometer, that is this distance. Okay. Now, after meeting, Q has to cover this distance, that is V1T kilometer, and P has to cover this distance, that is V2T kilometer. Okay. Now, as given, P is covering this distance, that is V2T kilometer in X hours. So what is the speed of P? That is V2T by X. That is the speed of P, and we have assumed the speed of P as V1. That means it is V1. Okay. Similarly, Q is covering this distance, that is V1T kilometer in Y hours. Okay. So what is the speed of Q? It is V1T by Y. And we have assumed the speed of Q as V2. That means it is V2. Now, from here, V1 by V2 is T by X. And from here, V1 by V2 is equal to Y by T. Okay. Now, we multiply both the expressions. So we'll be getting, just a moment, V1 by V2 whole square is equal to T by X into Y by T. Okay. So that means V1 by V2 is equal to square root of Y by X. Okay. So we have derived this formula, that is speed of first by speed of second, that is V1 by V2 is equal to root of Y by X. Okay. So it's a very simple concept. Further, I would advise you not to mug up the formula. Whenever the question is there, you just can take a call at the same time only. Friends, some basic conversions are given over here which we'll be using while solving the questions. So 1 hour is 60 minutes, that is 3600 seconds, that you might be knowing. 1 kilometers is 1000 meters. 1 kilometer is 0.6214 miles, that is around 0.6 miles. 1 yard is around 3 feet, and 1 kilometer per hour is around 5 by 8 miles per hour, or 1 mile per hour is 22 by 15 feet per second. Okay. So generally we are using the units, that is kilometers, meters, hours and seconds. Okay. We generally do not use yards and miles. Okay. So if you are appearing for any international exam, that is GRE, GMAT, in this sort of exams, these sort of units are used, that is yard and miles. Okay. As far as Indian exams are concerned, most of the units which are being used are kilometers, meters, hours and seconds. Okay. Now let's discuss the concepts of trains. Friends, while we deal with the problems of trains, the length of trains is a significant factor. Okay. Since it is not negligible, if we talk about human beings or cars or scooters, their width or their length is negligible. That's why we generally do not consider their width or length. But in case of trains, their length is not negligible. Sometimes it is in meters and sometimes it is in kilometers. Maybe 1200 meters, maybe 1500 meters, like this. So suppose if a train is crossing a stationary object or a pole, that means the time taken by it, that is, suppose the length of this particular train is X, then time taken by this particular train in passing a signal post or a pole is the same as the time taken by train to cover X meters with its own speed. Okay. So let's see the diagram over here. It is the length train AB whose length is x meters, and it has to cover this particular pole. Okay, so after covering, what will be the scene? Just see the diagram. Now just see here. This is the train AB with length x meters, and this is a point where the last bogie of train ends. Okay, and here it is engine. Okay, now this is train AB, the length of this train x meter, and this is the distance on platform, that is also x meters. Okay, so this is train, this is platform. Now this train is crossing this particular pole, and after crossing, the situation is like this. Okay, the bogies, last bogie is over here, and the engine of the train is over here. That means the train is moving for x meters. Okay, so as we talked while we solve the questions of trains, the length of the train is a significant part. Okay, so I hope you must be getting the concept. Let's take one example for it. Now, suppose a train going towards Jaipur is 1200 meters long, and on the way it passes a signal post at a speed of 40 km per hour. Find the time taken by a train to pass the signal post. Now suppose this is the train, and the length of this particular train is 1200 meters. Okay. Now to pass this particular pole, the entire train has to be crossed. Okay. So at the speed of 40 km per hour, how much time will it take to cover 1200 meters? First of all, units of both the quantities must be same. Okay. So let's convert the speed in kilometer per hour to meter per second. So if we wish to convert kilometer per hour to meter per second, we multiply it by 5 by 18. Okay. So it is the length of the train, or we can say it is a distance to be crossed. So time will be distance by speed. Okay, so it is distance by speed, that is 40 km per hour, and we convert 40 km per hour to meter per second. So 108 seconds will be taken by that particular train to cross this particular pole. I hope you are getting my point. Friends, here the width of this particular pole is negligible. Only the point to be consideration is the length of the train. In some cases, the train has to cross a platform, a bridge, or something, a road or something like that. Okay, so in those particular cases, even the length of the platform or bridge has to be considered. Okay, let's say, let's take the concept. Now let's see what happens when a train is crossing a platform or a tunnel or a bridge. Okay, now time taken by a train x meters long in passing a stationary y meters long platform or bridge or tunnel is the same as the time taken by the train to cover x plus y meters with its own speed. Now friends, let's assume that it is a train and the length of this train is x meters. And this is a platform or maybe a bridge or tunnel, and length of it is y meters. Now this train has to cross this particular platform or tunnel. Okay, now what is the scene? That means this particular point should be crossed. Okay, so after crossing, the scene will be like this. Suppose this is A and B, that is maybe here the last bogie of the train is there, and here it is A and B. That means this particular point is, first of all, it is moving to x meters to reach over here, then to reach over here it is moving y meters. That means this particular point is running for x meters, then y meters to reach over here. That means this train will take this train will move x plus y meters to cross this particular platform. Okay. Okay, so that time taken by this train in passing this platform or tunnel or bridge is the same as the time taken by train to cover x plus y meters with its own speed. Since we have discussed that this point will be covering x plus y distance, and whatever is the speed of the train, according to that, it will take time to cross this platform. Okay. This can be a stationary platform, it can be a bridge, it can be a tunnel, and it can be even other train which is just standing over there. Okay, so in all the cases, the total distance which this last point has to cover is x plus y meters. Okay. Now, friends, next very important concept is the concept of relative speed. Okay, relative speed means the difference or the addition of the speeds of two bodies. Okay, now let's try to understand it. Suppose two trains or bodies are moving in the same direction at u kilometer per hour and v kilometer per hour respectively, and u is greater than v, then their relative speed is u minus v kilometer per hour, provided they are moving in the same direction. Now, why does it happen? Let's try to understand it. Now, suppose two persons are there, maybe A and B. Okay, so both of them are over here initially. Now A is walking at say 5 kilometer per hour across this road, and B is walking at maybe 2 kilometer per hour. Okay, and they started simultaneously. Now what would happen, friends? After 1 hour, what will be the situation? Where will be A and where will be B? Since A is walking at 5 kilometer per hour speed, A might have crossed 5 kilometer. Okay, suppose this is 5 kilometer. And since B is walking at 2 kilometer per hour, so after 1 hour, B will be somewhere here. Okay, so now what is the difference between these two? It is 3 kilometer. Now how did we get this 3 kilometer? That is the difference between their speeds. So every hour they are getting apart from 3 kilometer. Okay, are you getting my point? So in 2 hours they will be 6 kilometers apart, and in 3 hours they will be 9 kilometers apart. Okay, so this difference per hour is their relative speed. Okay, this difference in their speeds is their relative speed. Okay, that means every hour A is running 3 more kilometer than B. Okay, or we can say A is gaining 3 kilometers per hour than from B. Okay. Let's take one more example over here. Suppose two persons are there, A and B. Speed of A is 4 kilometer per hour and speed of B is maybe 6 kilometer per hour. Okay. Now, suppose A is starting from this place. Let's assume at 9 o'clock. Okay. Okay, so A is starting at 9 o'clock, and suppose B is starting at 10 o'clock. Just listen to me very carefully. A is starting from this point at 9 o'clock with the speed of 4 kilometer per hour, and B is starting from the same point at 10 o'clock at the speed then 6 kilometer per hour. Now we just have to find when they will meet. That means, or we can say when B will cross A. Okay. Now just listen to me carefully. B is starting 1 hour after A. That means in 1 hour A might have run 4 kilometers since his speed is 4 kilometer per hour. So A will be 4 kilometer from this place. Okay, when B is starting. When B is starting, the difference between A and B is 4 kilometer. Now to meet A, B has to cover this 4 kilometer, but A is also not going to stop. A is still moving. That means B has to cover this 4 kilometer extra. Okay, that means he has to gain this 4 kilometer from A. You're getting my point? Now, what is the gaining speed of B? That is 2 kilometer per hour. That means every hour B is running 2 kilometer extra than A. Okay, that means to run 4 kilometer, B has to walk for, or B has to run for 2 hours. Okay. Okay, so I would just make a recap over here. Since the gaining speed of B is 2 kilometer per hour, that means every hour B is running 2 kilometers more than A. So to run 4 kilometers more than A, B has to run for 2 hours. Okay, since A is not going to stop, that's why we are considering their relative speed. Now this is a concept of relative speed, and in this case both of them are moving in the same direction. That's why we are taking their difference, and why we are taking their difference we have already discussed. Okay, so I hope you must be clear about the concept of relative speed when two bodies are moving in the same direction. Okay, now let's see what happens when the bodies are coming from the opposite directions. Now suppose two trains or bodies are moving in opposite direction at u kilometer per hour and v kilometer per hour, then their relative speed is u plus v kilometer per hour. Suppose this is a point A and this is a point B. Okay. Now maybe a person, say P1 is coming from this direction and a person P2 is coming from this direction. Now we have to find out when and where they will meet. Suppose they are meeting somewhere over here. Okay. Now suppose speed of P1 is V1 and speed of P2 is V2. Okay. And the total distance between A and B is suppose D. Okay. Now let's assume both of them are meeting after T hours. Speed of P1 is V1 kilometer per hour, speed of P2 is V2 kilometer per hour, and the distance between these 2 points is D kilometer, and they are meeting after T hours. Okay. Now P1 will run how much in T hours with the speed of V1? He will be running for V1T kilometers, and this person will be running for V2T kilometer. Okay. Now what is the total distance which they are covering? That is V1T kilometer plus V2T kilometer. That is V1 plus V2T kilometers. Okay, V1 plus V2T kilometers. Now exactly what is this? This is the same distance. That means some of the part of this distance is covered by P1 and some of the part is covered by P2. So it is T. Okay, so if two bodies are coming from opposite direction, the relative speeds is addition of their speed. Okay. Now let's take a practical numerical example over here. Now let's take this example. Suppose two persons are there, A and B, and the distance between them as of now is say 30 kilometers. Okay, and let's assume the speed of A is 5 kilometer per hour and speed of B is 10 kilometer per hour. Okay, now both of them are starting simultaneously to meet each other. Okay, definitely they are going to meet somewhere in between. Maybe they meet here, here, or here. Let's assume they meet here. Okay, because A might be running a less distance than B. Okay, so they will be meeting somewhere here. Let's assume it to be point O. Okay. Now just try to find out what will be the scene after 1 kilometer. Since A is running at the speed of 5 kilometer per hour, A will be 5 kilometer far from this place, somewhere here. Okay, and B will be 10 kilometer far from this place, somewhere here. Now what is the distance between them? 5 kilometer A is getting closer and 10 kilometers B is getting closer. That means overall they are getting closer by 15 kilometer. Now what is the distance left between them is 15 kilometer only. Okay. Now how do we get this 15 kilometer? Friends, this is nothing else but their relative speed. Every hour they are getting closer by 15 kilometers. Since 5 kilometer A is approaching towards B and 10 kilometers per hour B is approaching towards A. That means for every hour both of them are running 15 kilometers towards each other. Okay. So to cover 13 kilometer, they need just 2 hours. Okay. So if they start simultaneously with these speeds, they'll be meeting somewhere here after 2 hours. Okay. So in 2 hours, A might have run 10 kilometers and B might have run 20 kilometers with their respective speeds. So I hope you are getting my point. The concept of relative speed, if two bodies are approaching towards each other, their relative speed is the addition of their speed. And if two bodies are moving apart from each other, then the relative speed is further the addition of their speeds. Okay. And if two bodies are moving in the same direction, then the relative speed will be difference between their speeds. Okay. Now friends, let's revise the concept. If two bodies are coming like this, then it's a relative speed with addition, that is addition of their speed. If two bodies are going like this, then the relative speed will be, suppose it is u, it is v, then the relative speed will be u minus v. And if two bodies are going like this, then also their relative speed will be u plus v. So if they are approaching towards each other, the relative speeds will be addition of their speeds. If they are moving apart from each other, still the relative speed will be addition of their speed. And if they are going in the same direction, their relative speed will be difference between their speeds. Okay. So once again, no need to mug up any sort of formula in this case. Just try to go logically. Friends, I hope you might have enjoyed the session of time, speed and distance. In our next session, we'll be taking some applications of the topic. Do revise this particular session so you'll be more comfortable to attend the problem solving session of time, speed and distance. Bye-bye.